A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi, we have learned the image formation and properties of different mirrors and the uses of mirrors in different situations. So now, we are familiar with the distances and points related to mirrors. But how do these distances measure? Do we need to take any direction for these measurements? There is an internationally accepted system for these measurements. This is called the New Cartesian Sign Convention. These are applicable to both mirrors and lenses. Let's see what are the main points related to New Cartesian Sign Convention. In experiments related to mirrors and lenses, the distances are measured in the same manner as in a graph. In a graph, all the distances are measured from the origin. In case of mirrors, the pole is taken as the origin. If we consider a graph, the pole of the mirror will coincide with the origin of the graph. Therefore, all the distances are to be measured from the pole. As per the convention, the light ray is assumed to travel from left to right. Therefore, all the distances measured along the direction of incident light is taken as positive and that in the opposite direction is taken as negative. If we consider this as a graph, the distances measured from the pole to the right are taken as positive and from the pole to the left are taken as negative. The distances measured upward from the x-axis are taken as positive and those measured downward are taken as negative. We have seen that the incident ray is always from left to right. So, the object should be placed to the left of the mirror. Distances are to be measured from the pole. Incident ray is from object to the pole. So, the direction of distance from the mirror to the object will be negative. We usually denote the object distance by the letter U. So, U will be negative for a mirror. The rays incident on a concave mirror from the left will converge on the principal focus of the left side. So, the focal length is to be measured from the pole to the left. That's why the focal length of a concave mirror is always negative. In case of a convex mirror, the rays incident on a convex mirror from the left will diverge and appear to originate from the principal focus on the right side. So, the focal length is to be measured from the pole to the right. That's why the focal length of a convex mirror is always positive. The position of the image is not constant. It will vary with the position of the object. We usually denote the image distance by the letter V. If the image is formed to the left to the mirror, V will be negative, and if the image is formed right to the mirror, V will be positive. The height of the image will be positive if it is formed above the principal axis, and it will be negative if it is formed below the principal axis. Let's consider an example. You can see a concave mirror here. The object is placed 60 centimeters away from the mirror. Since the object is placed to the left side of the mirror, the sign of U is taken as negative. So, U is equal to negative 60 centimeters. Here, the image is formed at a distance of 20 centimeters from the mirror. Since the image is formed to the right, the sign of V can be taken as positive. So, V is equal to positive 20 centimeters. If we measure the focal length, the distance will be 15 centimeters. The focal length of a concave mirror is always negative. So, F is equal to negative 15 centimeters. And the radius of curvature R is negative 30 centimeters. Here, the object is placed above the principal axis. So, the height can be taken as positive. Height of the object HO is equal to positive 12 centimeters. The image is formed below the principal axis, which means the image is an inverted one. The height of the image can be taken as negative. The height of the image HI is equal to negative 4 centimeters. Whenever the mirrors are used, the focal length must be determined. Through some experiments, it was found out that the value of UV divided by U plus V is equal to the focal length of the mirror. That is, F is equal to uv divided by u plus v. If we rearrange the terms, we will get an equation like 1 divided by f is equal to 1 divided by u plus 1 divided by v. This is called the mirror formula. We can use these equations to solve the questions related to mirrors. We can solve a problem for a better understanding. The object is placed at a distance of 20 centimeters from a concave mirror which has a focal length of 40 centimeters. Find the position and characteristics of the image. The image given here is a concave mirror. The focal length of a concave mirror is always negative. So, we can write the focal length f is equal to negative 40 centimeters. We are given the object is placed at a distance of 20 centimeters from the mirror. For a mirror, the object is placed to the mirror. That is, the sign of u will be negative. So, the object distance u is equal to negative 20 centimeters. Here, the object distance is smaller than the focal length. That is, the object is placed between the focus and the pole. If the object is placed between the focus and the pole, the image formed will be visual, erect and enlarged. So, let's find out the exact position of the image. We can use the mirror formula here. Here, u is equal to negative 20 centimeters and f is equal to negative 40 centimeters. We have the mirror formula 1 divided by f is equal to 1 divided by u plus 1 divided by v. That is, 1 divided by negative 40 is equal to 1 divided by negative 20 plus 1 divided by v. So, 1 divided by v is equal to 1 divided by negative 40 minus 1 divided by negative 20. So, 1 divided by negative 40 plus 1 divided by 20. We can rearrange this as 1 divided by 20 minus 1 divided by 40, which is equal to 1 divided by 40. So, we get the value of v as positive 40 centimeters. That is, the image is formed at a distance of 40 centimeters right to the lens. Image will be visual, erect and enlarged. So, in this session, we have learned the procedures we should follow while measuring the distances related to mirrors, which is the new Cartesian sign convention, and how to solve the problems related to mirrors using mirror formula. See you later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാബ്സ് ദ ലേണിംഗ് ആപ്പ്.